All right, so it still looks like this particular screen does not want to connect to the internet for whatever reason. So we're going to continue on with the handwritten notes on the board until they get this resolved. So let me just pull up one little thing here on my personal computer. And we can go ahead and get started. All right, so last time we talked about linear equations. Someone go ahead and remind me, what is a linear equation, or give me an example of a linear equation. Yeah, ax plus b equals 0, or something like, I don't know, 3x minus 7 is equal to 0. Something that matched that particular form. So one key thing about that linear equation is that we had x to the 1 power. It wasn't an x squared. It was not an x cubed. It was not an x to the 7th power. It was just a single x to the 1 power. Yeah, I might have had to move some stuff around and play around with it, but in the end, it was x to the 1 power. So for today, we're going to go ahead and continue studying our equations, and we're going to look at 1.2 quadratic equations. We're going to talk about what is a quadratic equation, and then we're going to go step by step. How do we solve these types of equations? How are they different from a linear equation? How are they the same? And as it turns out, one of the big key differences between a linear equation and a quadratic equation is that quadratic equations have an x squared. Before we had x to the 1, now we got an x to the 2nd power. So let's go ahead and put out the formal definition. Full definition of a quadratic equation. Well, a quadratic equation Well, first off, it's an equation, not a big surprise. That can be written as the form ax squared plus bx plus c is equal to 0, where a, b, c are real numbers. Remember that this fancy notation here just means a, b, and c are real. And we put the extra condition that a is not 0. So a, b, and c, these are some real numbers. You can think of whatever your favorite numbers are, 1, 2, 3, for example. If I plug in 1, 2, and 3 for a, b, and c, that gives me a quadratic equation. So I have my definition. And just like a linear equation, I want to emphasize this thing where it says it can be written in this way. It might not look like this right away, but if I can rearrange it so that it does look like a number times x squared, plus a number times x, plus or minus another number equal to 0, then it is a quadratic equation. The other thing I want to mention here is that last little note I have. I do not want the first number, a, to be 0. Why do I not want a to be 0? Any ideas? Well, what happens? What was that? 0 is still a real number for us. What happens whenever a is 0? Let's see, I get 0 times x squared. What's 0 times x squared? 0. So if a is 0, then this whole first part is gone, right? And then I would be left with, well, a linear equation. But I don't want a linear equation. I want to deal with a quadratic equation. If that first number is 0, I'm no longer quadratic. I am just linear. So that's why I say that I want that first number to be not 0. If it's not 0, then it's something we've worked with already. I mean, if it is 0, it's something we've worked with already. So here we have the quadratic equation, ax squared plus bx plus c equal to 0. And the way I've actually written it here, we actually have a special name for this form. We actually call this the standard form. So if you ever hear me say the word standard form, I am saying for it to look like ax squared plus bx plus c equal to 0. So we have quadratic equations. A quick example, like I said, you can plug in whatever numbers you want. If I wrote negative 3x squared plus 1/2 x minus 2 equal to 0, that's still quadratic. It's not a very nice one, but it's quadratic. It's a number times x squared plus a number times x plus another plain number, plus or minus really, equal to 0. One other key difference I'm noticing here for a quadratic equation, for a linear equation, I just had basically one x to the 1. But for quadratic, I can have an x, I have an x squared, and I can also have an x. So clearly we have a linear equation is different from a quadratic equation based off this definition. One has x squared, one does not. All right, so we have our definition. So just like how last time our focus was how do I solve a linear equation, my focus here is how am I going to solve a quadratic equation. And in particular, we're going to talk about 3 different methods. Technically, there is a 4th method that you might have heard, but we're not really going to go really deep into that one. So to figure this out, let's go ahead and start with an example. So example 1. Instruction, solve for x. At this point in the class, all we've done is solve equations, so we're trying to figure out what is x equal to. And let's say I have the equation, let's do x squared minus 19 is equal to 0. So this is quadratic, it has an x squared in it. But the question is going to be, how can I solve this? In what ways is it different from how I might solve a linear equation? And how might it be similar? So to start us off here, I'm going to start off with one quick question about this. How many types of x's do you see in this equation? Well, I just see one x, right? There's one type of x, an x squared. So the rule of thumb I like to do to introduce equations to students is if there's one type of x, then we're going to solve it the same way as before. Move the x's to one side and then the numbers to the other. So here there's only one type of x. So let's go ahead and split them up. Yeah, we can go ahead and add 19, for example. If I add 19 to the left and to the right, again, it's an equation. I have to do it to both sides. I get x squared is equal to, well, 19. All right, so that's really nice. My end goal is x equal to something. I'm almost there. I got an x squared. So somehow I've got to get rid of the square power. What's the opposite of a square? A square root. So using that idea of opposites, I'm going to do a square root on the left and the right. Just like how before, opposite of plus is minus, opposite of a square is a square root. So I'm applying that operation. So I said it 2 times already. I'll say it again. Square root and a square cancel each other out, leaving me with an x. On the right side, there's a couple of parts I want to mention about this. First off, square root of 19, that's not a clean number. That's not like square root of 4 or square root of 16. In fact, 19 is a prime number. I can't really break it down any type of way. So I'm actually going to leave it as a square root of 19. So far I have x is equal to the square root of 19. Now, the next question I'll ask is there anything I'm missing from my final answer? Does anyone know what's missing from here? Square root of 19 is definitely a correct answer, but I'm claiming I'm missing one other answer. Anyone have an idea what that one other answer might be? Well, if I look at this, the answer that I'm actually missing is not only am I using positive 19, but I also should include negative 19. Or in other words, I can write plus or minus here. We're going to talk about why do I include the plus or minus. The reason that I include plus or minus, that symbol right there, if I check my answer, if I plug in square root of 19 into here, square root of 19 squared, I get 19. 19 minus 19, I get 0. That's great. What happens whenever I plug in negative square root of 19? Well, negative square root of 19 squared minus 19. Is that still equal to 0? Yeah, so negative square root of 19 squared, that's negative square root times the negative square root, which gives me a positive 19 in particular. Is that equal to 0? And for sure, 0 is equal to 0. So in other words, I have two answers, positive square root of 19 and negative square root of 19. So this brings me to a nice rule about the squaring and square root. If you ever introduce a square root, this problem originally did not have a square root, but if I ever introduce one, I have to put plus or minus there. Here, I introduced a square root, so I have to put plus or minus as part of my final answer. So really, I have two answers, square root of 19 and negative square root of 19. So this is example 1. Any questions about how I worked out this particular example? We were really able to separate them because there was only one type of x. If there's multiple types of x's, then we have to change our plan and how we're going to solve it. The other thing I want to mention about this, whenever we did linear equations last time, it was x to the 1 power. And I only had, at most, one answer. Here for a quadratic, I have x to the 2nd power squared. That tells me that I have at most two answers, or in this case, positive square root of 19 or negative square root of 19. So actually the power tells me what's the most number of answers I might have. I could only have one answer, but I have at most two. Using that idea, if I had an x cubed, what's the maximum number of answers I could get if it was x to the 3? 3. If I had x to the 4, that means I have at most 4 answers, so on and so on. I don't always have two answers, but I have at most two. All right, so that was example 1. Now let's go ahead and talk about example 2. Same instructions, solve for x. And let's go ahead and deal with this problem. Let's say I have x squared minus 8x. Let's do plus 12 is equal to 0. So I'm going to start off with the same question as last time. How many types of x's do I see here? 2. There's an x squared and there's an x. Whenever there are multiple types of x's, this means I'm not splitting up my numbers and my letters. Instead, I'm going to push everything to one side. And in this case, it's already pushed to one side. I have my numbers and my letters on one side already. And the other side just has a plain 0. So since that's already done, now the question is, how can I solve this? So this is how we're going to start introducing our first way to solve a quadratic. Starts with f. Anyone know what it's called? Factoring. So we're going to learn, how do I factor this expression, this polynomial? So fortunately for this one we can factor pretty nicely. Whenever I say I want to factor a polynomial like this, I'm saying I want to split this down, in particular for this one, into 2 parts, where if I multiply them together, I get this whole thing. So we're going to break down, how do I know what goes into these 2 blanks? If you want to have a very technical term here, what I have on top is a trinomial. Tri for 3 parts, the first, the second, and the third. I'm trying to break these down into 2 separate binomials. So something that has 2 parts each. So if I look at this one, the things I'm going to recognize first, there's going to be basically 4 blanks here. Blank 1, blank 2, blank 3, blank 4. And remember, to factor this, I want something where if I write it out, and if you remember the word, multiply it out or FOIL it, it brings me back to the original. So I know the first F stands for first times the first. I want these 2 things to multiply to give me that piece right here. So the question is, how do I multiply 2 things to get me x squared? My first thought was that, yeah, x times x, right? That gives me x squared. So in this blank, I'm going to put x, and I'm going to put x. That covers the f. First times first gives me the x squared. Now I'm going to focus on this last here, L, for last times the last. I know the last 2 parts, whatever goes in these 2, has to give me positive 12. So I'm going to write this on the side as scratch work. 2 numbers that multiply to give me 12. Yes, so it is going to end up being -2 and -6. I'm just going to go through the steps on how we might do the elimination and how we figure out each one. So for 12, ways to make 12 with whole numbers. 12 times 1. I don't know why I changed the color. 12 times 1, 6 times 2, 3 times 4. So those are the things that multiply to give me positive 12. But how do I know which one of these 3 groups they give me? Yeah, so I have to look in the middle now. These numbers have to add up to give me -8. So in other words, I know that both of these have to be negative. That's still fine because negative times a negative, still positive. So which one of these 3 groups, pairs, will add together to give me -8? Yeah, -6 and -2. So -6, -2. Or you could put x minus 2, x minus 6. It doesn't really matter. 2 times 3, same thing as 3 times 2. It doesn't matter for the order. So what we just did is we factored this trinomial. So we have this here. Now we can go ahead and actually move on to solving the equation. And the good thing about factoring is after that next line that we just wrote, we've done the hard work for the problem. And if you want, you can always check your answer. If you multiply this all out, we definitely get back up to here. First times first, x squared. Outside, -2 plus -6, -8. -6 times -2, +12. So that definitely gives me what I need. Now the next thing is, how do I move on from here? Well, right here, all I've stated is I have one number times another number is equal to 0. For this equation to be true, that means either this has to be 0 or this has to be 0. In other words, I can write x minus 6 is 0 and or x minus 2 is 0. Because the only way for this equation to make sense is something times 0 gives me 0. So one of them has to be 0. And now we just have two very quick linear equations to solve. What's the answer that I get from the one on the left? So here, if I want to solve for x, we're going to add 6. I'm just writing this for notes. We had x is a positive 6. So we don't put plus or minus because I didn't introduce a square root. That's only whenever I draw that little square root symbol. If I don't do that, I don't need to worry about plus or minus yet. What do I get from over here on the right? Yeah, we get +2. If you want it for notes, you just do +2 on the left and the right. So I got two answers, which is what I expected. It's an x squared, meaning I have at most two answers. It could be one answer, but it's at most two. If you're getting a third answer, then something's going wrong. All right, so that was example 2. And actually, this is our review of factoring. All right, so we just reviewed an example of factoring. But for those of you that might be really good with factoring, you might be looking at this and saying, well, this example was really easy. What happens for the more complicated ones? Well, there's a good thing and a bad thing about factoring. For an example like this, x squared minus 8x plus 12, we can probably factor that pretty quickly. We only had so many options. Pretty much because there's only so many ways you can make 12. We had 3 ways to make 12. But you can imagine, what if I gave, instead of 12 at the end, it was 2000. There's a lot of different ways that you can make 2000 with a lot of different pairs of numbers. So one of the cons of factoring is that if you have really large numbers at the end and the beginning, sometimes it can be a little bit of a guessing game where you're guessing which numbers and then you're just checking it through. So for examples like this where it might be a little bit more obvious, yeah, factoring is good, but for the more complicated examples, maybe we might want to use a different method. All right, so this was example 2. Now let's go ahead and talk about our second way that we can solve a quadratic. So the second way that I might solve a quadratic, we actually used this earlier in example 1. I'm going to call this the square root method. Square root method. So you can probably guess what's going to happen in this square root method. Well, in the name, we're going to use a square root. And we used that for that first example, where we had x squared minus 19 equal to 0. So a little bit about the square root method. I know that let's put this as a note, if I ever get that x squared is equal to a number, let's call it c. Based off what we did, then I know that x is equal to plus or minus the square root of c, because I'm introducing that square root. I put a square root to get rid of my square. Because I introduced a square root, I have to put the plus or minus symbol. So the square root method is going to be derived from what I have here. But we know that I don't always just have x squared and a number. We saw in that previous example, example 2, I had x squared, I had an x, and I had a number. So the first thing I'll note here is that the square root method for us will only work if I have a single type of x. In fact, I can actually expand this expression if I have something in here in parentheses. I don't know what's in these parentheses. It could be any expression. If this is true, then if I follow the same pattern, that same thing, whatever something it is, that's equal to plus or minus the square root of c. So this is me emphasizing you can only use the square root method if you can have one thing squared equal to a number. We have it actually right here, one thing squared equal to a number. An example of what this might look like is, you don't have to write this, it's just an example. I have something squared equal to a number. What I have here would be an example of something that I can use the square root method. And we'll do an example with it in example 3 in just a moment. So this benefits from the fact, if I use that as an example, there's only one type of x that I'm seeing. I'm not seeing two types of x's. I'll give y'all a moment for anyone to copy this down. So this is what we somewhat of an exploitation of the square. All right, so now that we're introduced to the square root method, let's go ahead and do an example so that we have it practiced. Example 3. I don't know why it keeps on changing colors, but that's fine. Same instructions as before, solve for x. You can probably imagine all the instructions are going to be the same for this today's lecture, solve for x. So what if I give you something that looks like this? -5 times x plus 8 squared is equal to, let's do -50. I've got something like this right here. All right, so looking at this, you might be tempted to say, let's go ahead and take the square root. But I have to be careful. Remember, I only want to take the square root if one side is everything squared equal to a number. Well, if I look on the left, there's a -5 in the way. So if I want to do the square root, I have to get rid of that -5 in the front. So someone give me a suggestion. How am I going to get rid of that -5 in the front? So looking at this, one thing that we do have to be careful about for distributing, we're actually not going to want to distribute -5 because remember, we have PEMDAS. Exponents happen first before multiplying. So I don't want to distribute that -5. So yeah, we're actually going to go ahead and divide by -5 because this is -5 times what I need. So if I want to get rid of that -5, I get x plus 8 squared. That's -5, cancels with -5. And then what's -50 divided by -5? Yeah, we get a nice +10. All right, so by dividing by -5, I definitely got something squared equal to a number. Once I get that whatever squared equal to a number, I can now do the square root. I can introduce it. So I'm going to do the square root on the left and the right. On the left, square and square root, they're opposites, so they cancel each other out, leaving me with x plus 8. And what am I going to write on the right side? What should I write? Yeah, so first off, square root of 10, that's not a perfect square root. That's not clean at all. So I know I have a square root of 10. And just like before, originally there was no square root, but I introduced one. When I introduce a square root, I need a plus minus symbol. This is great. We've done a lot of the hard work so far. Remember, my end goal is getting x by itself. There's one thing left in the way to get x by itself. What do I need to do? Yeah, there's a +8 here, opposite of +8, -8. And this is going to lead to the conversation, what am I doing on the right side? That looks like a really weird number, square root, plus or minus, and a -8. So we're actually going to keep it very simple here. First off, this isn't me writing like 2 plus 4. Those are whole numbers. This is a whole number plus or minus a square root. Actually, all I'm going to do is, well, I have -8 plus or minus the square root of 10. Because I can't really combine that really cleanly unless I use a decimal. So I have two answers still. -8 plus the square root of 10, and then the other one being -8 minus the square root of 10. If you want, you could write them separately, but most people prefer to write it in shorthand so they don't have to write it over and over again. If this was a whole number, if it was like -8 plus or minus 2, then yeah, I want to combine that because we can do -8 plus 2, -8 minus 2 really quick. But there's nothing we can really do here. So this is the square root method whenever I'm able to take the square root. All right, so we did factoring, we did the square root method. Both of them are really nice methods, but there's a problem with both of them. The square root method only works if it looks something like this. If I have something squared equal to 0, whenever I only have one type of x. Factoring works out well, but sometimes it gets really complicated, as you probably know already. And we can't always factor. Sometimes we can't factor at all. So if I can use them, it's great. But there's a lot of examples where they do not work. I can't even attempt to use them. This leads me into my third way that we're going to talk about how to solve a quadratic equation. And one that you've probably, more or less, depending on your experience, like or dislike. Does anyone know the name of the third method that I'm thinking of? Yeah, so that is the quadratic formula. I can tell you're all excited to visit this again. The quadratic formula. So the quadratic formula says if I have this, ax squared plus bx plus c is equal to 0. So if I have a quadratic equation, then let's see how many of y'all remember the quadratic formula from memory. X is equal to, what's the quadratic formula? Anyone remember it? There's a plus or minus in there for sure. Well, y'all definitely used the correct letters somewhere in there. So As a reminder, starting off negative b plus or minus. I'm acting like y'all are giving me the correct letters. Yes, correct. Y'all definitely use the letters A, B, and C somewhere in there. So I don't know why it keeps on changing color, but let me change that because that's bothering me. Let's see. 2. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember how I said that you're allowed to have a sheet with you for your exam? Maybe this is something you want to include. I don't know, but just a suggestion. How would I know? So we have quadratic formula. If I ever have this formula, ax squared plus bx plus c equal to 0, then I know what x is. So there's a good and a not so good thing about this quadratic formula. The good news about it is that it always works. Maybe the possible downside is, well, you have to remember what the quadratic formula is, but it will work out. The other thing about quadratic formula is that you can only use it after you wrote your equation like this. You have to have everything on one side equal to 0. If there's like a 7 on the right here, then I have to move that 7 first before I even look at this part. So we have the quadratic formula. All right, so we have the quadratic formula. Let's go ahead and do a quick example using the quadratic formula. If you haven't written this down yet, I suggest that you have this copied down because I'm going to be using it in the next example. All right, so this is our next example. Let's see, example. I lost count. I think this is example 4, if I'm right. If not, it's whatever the next number is. So for x, let's start off nice and quick. X squared minus 5x plus 6. Now, for y'all, those of y'all that are good at factoring, yes, you can factor this, but we're just doing practice with quadratic formula. So first off, is this in standard form? Is it everything on one side equal to 0? Yes. So since that is true, then I'm allowed to use a quadratic formula. Whenever we're talking about quadratic formula, I know that there's an A, B, C in there. So let's say what is A, what's B, and what's C. So what is A? So what's A? Is it x squared? Remember, our equation is usually ax squared, bx plus c. Yeah, it's always the number in front of the x's. So it's not actually the x's, it's the number in front. That's what we gotta be careful about. If you want, there's always an understood 1 whenever you don't see a number there. All right, so what's B? Yes. And C. Correct. Good thing, never forget your negatives also. Make sure you're including the negatives in your A, B, and C. All right, so we had it in standard form. We know what A, B, and C are. Now let's get to plugging it into the quadratic formula. Just for practice, I'm gonna write it again. Let's see, let's write it down here. So I have negative B. So negative 5. I'm being careful with my parentheses here. So this is negative B plus or minus the square root of B squared minus 4 times, what's A again? What's C? All over 2 times A. So this is me very directly saying plug in A, plug in B, plug in C. So a lot of students get to this point, everything's perfect. The next thing that a lot of students mess up is cleaning up this mess here. Before I do that, another mistake I want to mention, remember, it's this whole thing divided by 2a. I get a lot of students who say negative, negative, negative 5, leave that alone. And then, in other words, I have a lot of students who do this. And they don't do it over the entire expression. It's over everything. So make sure this goes all the way. All right, so let's go ahead and clean this up step by step. What's negative 5? Positive 5, because that's negative 1 times negative 5. I get a positive 5. That's great. Plus or minus the square root. What's negative 5 squared? Yeah, negative 5 times negative 5, I get 25. I'm going to take a quick pause right here. If you type that into your calculator, make sure you put parentheses negative 5 squared. Don't put this into your calculator. You want to put it as negative 5 squared. Because remember, calculator follows PEMDAS. It does the exponent, 25, and then times negative 1. But you want it to be negative 5 times negative 5. So make sure you're doing this one if you're using a calculator ever. All right, over here, negative 4 times 1 times 6. What does that give me? Yeah, negative 24. Going down the row, negative 4 times 1 is negative 4. Negative 4 times 6, I get negative 24. And that's still all underneath the square root. Yes. And then all over 2. I'm going to scoot this up. All right, so we're going to continue cleaning this up. What I'm going to focus on is what's inside that square root. So right here I have 5, not much changing. What's 25 minus 24? What's the square root of 1? Yeah, the square root of 1 is 1, because we know 1 times 1 is 1. So this is 5 plus or minus 1, all over 2. All right, so now I can take this a step further because 1 is a pretty clean number. I have to do 2 different ways. One where I do 5 plus 1, and the other one where I do 5 minus 1, because this is plus or minus. So what do I get whenever I do plus 1? Well, I get 5 plus 1, which is 6. Divided by 2, I get 3. So 3 is one of my answers. What about whenever I subtract 1? 5 minus 1, 4. 4 over 2, 2. So I get the answers 3 and 2. Well, technically 3 or 2, if I want to be mathematically correct. Again, I expected at most 2 answers. All right, so any questions about how I use the quadratic formula for this example? Yeah. Let me shift this down like so. All right, so that's all the time we have for today. This is what we will be doing for quadratic formula. There is a fourth method that we don't really talk about, calling it, like you might have heard it called the AC method. We're not going to worry about that method. Next time, we're going to talk about what happens if there's a negative underneath the square root. We're going to be introduced very briefly to what is an imaginary number and how does it relate to a quadratic formula. But besides that, that's all for today. Obviously no homework because I just got access to Blackboard basically yesterday. Probably on Monday, I'll start assigning homework and everything like that. Besides that, have a good weekend.